In this section, we are looking at exponents and specifically zero and negative exponents. Let's begin by looking at the zero exponent rule. This rule tells us that any base that is a non-zero base raised to the 0th power will always be 1. So let's look at why this is the case. Going back to our quotient rule for exponents, we know that if we have like bases that are being divided by each other, that you subtract the exponent in the denominator from the exponent in the numerator. And if we do that here, we get 2 to the 3 minus 3rd power, which really is just 2 to the 0th power. Now, if we go and take this same problem and write it out in long form, we know 2 to the 3rd power is 2 times 2 times 2. And then in the denominator, again, we have 2 to the 3rd power, so 2 times 2 times 2. And we can notice that all of these have common factors. And so we are left with that being equal to 1. So again, we know that if we end up with 2 to the 0, it must be 1. And a reminder that if you have x to the 1, that is just going to give you that same base of x. The next rule we want to look at is the negative integer exponent rule. And with this, we take any base that has a negative exponent, but the base must be a non-zero real number and the n in the exponent must be an integer. So the rule is you take the reciprocal of it and in the denominator make the exponent positive. So let's look at why this works down at this example. Again, we'll be using the quotient rule for exponents. So that means the exponent in the denominator is being subtracted from the exponent in the numerator, but keeping that like base of 4. So we have 4 to the 3 minus 5 power, which gives us 4 to the negative 2nd power. Now, if we take that same problem over on this side and just write it out, we have 4 to the 3rd power, which we know means 4 times 4 times 4 in the numerator, and then 4 to the 5th power in the denominator, so multiply 4 together 5 times. As you can see when it's written out, we have common factors of 4 in the top and bottom, so that leaves us with 1 times 1 times 1 in the numerator, 1 times 1 times 1 times 4 in the denominator. So the numerator is going to be 1, where the denominator we have 2 4's left, so that an exponential is going to be 4 to the 2nd power. Therefore, we know that this 1 divided by 4 to the 2nd power must equal 4 to the negative 2nd power, which therefore proves the negative integer exponent rule. Now, when you're utilizing this rule, you need to be cautious about mistakes that often happen. Oftentimes, people will look at, for example, 3 to the negative 2nd power and just bring that negative sign out in front of the base. However, that is not how it works. Instead, you take the reciprocal, so 1 over 3 to the 2nd power, and we know 3 to the 2nd power, or 3 squared, it's really 3 times 3, so it would be 1 over 9. Another common mistake in this one is people will take 3 to the 2nd power, but then apply the negative out in front after they do 3 to the 2nd power. But again, 3 to the 2nd power is really 1 divided by 3 to the positive 2nd power, and that gives us 1 to the 9th.